Now that we've talked about how density curves work and the basic idea of a normal distribution, we're going to spend a lot more time talking about how to calculate probabilities that use normal distributions. And so we're going to do a lot of this on the calculator, and I'm going to do a lot of examples because it takes a little getting used to on how we do these calculations. And I already talked about this in the last video, but the book uses a z-score method that uses z-scores and tables in the back of the book. You don't need to worry about that. The calculator doesn't require z-scores. It does all of the calculations behind the scenes so that you don't have to worry about that. Because we're using the calculator so much, it may be a little difficult to follow what's going on in the textbook. They'll still draw the same pictures, and their interpretations after they've solved the problem will still be correct, but you'll want to come back to this video to go through how to actually solve these on the calculator. There are two different types of problems that we do with normal distributions, and so in this video we're going to focus on finding the probability that a value falls in a certain part of the distribution. To get you used to how to set these up, I'm going to start with some generic examples. They don't have word problems to go with them, just to look at what we're looking for in the normal curve and how to find that. First, I'm going to run through some examples where we just look at how to draw the pictures to represent what we're looking for, and then we'll come back later and talk about how to actually calculate those. So on this one, let's say we want to deal with a normal curve with a mean of 3.1 and a standard deviation of 0.6. And I want to know the area between 2.3 and 2.9, or I want to know the probability of falling between 2.3 and 2.9, because those are really the same question. So the first thing I need to do then is draw a normal curve. So I draw a normal curve and I draw a line down the center, and that line represents where the mean is. So I'm going to label that with the mean of 3.1. And then I need to figure out where would 2.3 and 2.9 be in relationship to that. So they're smaller than 3.1, so they would both be over on the left. So I end up with a picture like this, where I've got the 3.1 down the center, and then 2.3 and 2.9 are both over on the left, and I've shaded in between them because I'm looking for the probability of falling in between those two values. And we don't always have two values that we want to be in between. On this one, we want to know the probability that x is greater than or equal to 3.5, or the area to the right of 3.5. So same curve with the 3.1 down the middle. 3.5 would be a little bit to the right of that, and I want to know the probability of being larger than that, so I'm going to shade that in. And remember, with continuous probability distributions, the difference between greater than versus greater than or equal to 3.5 really doesn't matter, so we would shade the same for both. We can do the same thing going the other direction. If we want to know the probability of x being less than or equal to 2.8, find 2.8, it's somewhere to the left, and then shade to the left of 2.8. And the scale doesn't really matter here. If you get the 2.8 a little too close or a little too far away, it doesn't matter. We're just looking for a basic idea of what's going on. Sometimes you might run into a situation where you actually start on one side of the mean and then shade across it onto the other side. So here we're looking for the probability that x is greater than or equal to 2.1. Well, 2.1 is to the left of the mean in this picture, but then if I'm shading to the right of that, it would cross over the mean and keep on going. So I end up with a very large shaded portion on those. Okay, so let's talk about how we would actually calculate these on the calculator. So the function that we're going to be using is in the distributions menu. That's the same place that your binomes were in. And so you'd hit second vars to open the distribution menu. And we're going to be using Normalcdf. We're not going to use normal PDF. Remember, PDF told you the probability of being at exactly 1 point. And with continuous probability distributions, you would be finding the probability that x is 3.1111111, which is really meaningless because there are so many other things right there nearby. So we'll always be doing Normalcdf, which will be ranges. Now, normal CDF is a little different than binom CDF. Binom CDF found the probability of that number and lower. Normal CDF is different. It's still a cumulative function, but it finds the probability of being between 2 points. And it needs 4 different pieces of information. It needs the left and right endpoints, and then the mean and the standard deviation. And we're dealing with probabilities here, so like we talked about in the last couple of chapters, probabilities always get rounded to at least 3 significant digits, although if you do more, that's okay. On the newest versions of the TI-84, when you choose normal CDF, you'll get a pop-up screen like this first, where you can fill in the 4 values, the left endpoint, the right for lower and upper, fill in the mean and the standard deviation, go to paste and hit enter, and then it will fill in the normal CDF command with the parentheses for you, and then you'll just hit enter and everything will be the same from there. Where this gets tricky is adjusting when you don't want to be between 2 values, because we also had examples that were less than or more than, and that gets a little tricky, and we'll walk through some examples on how to deal with those cases. Okay, so let's go back to this example where we want the probability of being between 2.3 and 2.9. Well, between is what normal CDF does, so we can choose normal CDF, put in the lower and upper endpoints, so 2.3, comma, 2.9, comma, put in the mean, 3.1, comma, and the standard deviation, 0.6. Close the parentheses, hit enter, and you end up with 0.278 when you round to 3 significant digits. So there is approximately 27.8% chance that a random x value would fall between those 2 numbers. So let's talk about the cases where things aren't quite so easy. So coming back to the example where we wanted the probability of being greater than 3.5. Well, this one's a little more complicated because normal CDF doesn't find greater than, it finds between. So we have to find a way to adjust our calculation to get what we need. And this is where the idea that half the curve is 0.5 comes in. So if we look at what we want, we've got the region to the right of 3.5 shaded in, but the only part that we know for sure is half the curve, so we would have to shade in a little bit more to have an entire half of the curve. And we can use that idea. We can say, okay, I know that that would be 0.5, but then I need to subtract a little bit out. I need to subtract that red part out to leave me with the black shaded part that I need. So I'm going to use normal CDF to find the area of the red portion, because that portion is between 2 things. And then I can say, okay, I had half, I'm going to subtract out the red portion, and that's going to leave me with the black. So you're going to have 0.5 minus the normal CDF calculation, which will be from 3.1 to 3.5 with a mean of 3.1 and a standard deviation of 0.6. And then when you hit enter, you find that that's 0.252. So there's approximately a 25.2 chance of being in that black shaded region to the right of 3.5. Here we have a similar example but pointing the other direction. So we want the probability of being less than 2.8, so going from 2.8 to the left. Well, this time we still have another red chunk that if we started with 0.5, we would need to subtract out the red chunk to leave the black portion that we want. So we would do 0.5, half of the curve, minus normal CDF to find the piece between 2.8 and 3.1. That's the red portion we're trying to get rid of. Mean of 3.1, standard deviation of 0.6. And that takes out that red portion and leaves us with the black portion, which is 0.309 or 30.9%. What about those portions that were more than half? We started on the left of the mean and shaded all the way across it over to the right. Well, that's more than half, so I don't want to take a half and subtract something. I need to take a half and add on the extra portion that goes beyond 0.5. So if you look on the right, you've got 0.5 would be that blue portion on the right half. And then I need to add on that red part that is on the other side but is not a complete half. So for this one I'm going to do 0.5, which is the blue part, plus the red part, so normal CDF between 2.1 and 3.1, mean and standard deviation, and so that gives me 0.952 or 95.2%. And it makes sense that that came out to more than 50% because just looking at it you can see that that's more than half. So really what this all comes down to is whether you have more than half or less than half, and that decides whether you're going to add or subtract. So if something starts on one side of the mean and points away from the mean, then you have less than half and you'll subtract. But if it starts on one side of the mean and goes toward and across it, then you end up with those pictures with more than half and you're going to add. So it's really important to understand that picture. So you may need to go back and re-watch some of these, and it's going to take some work to get used to it. So now let's run through some word problem examples and kind of review all of this. So Beanstalk Club, group for tall people, have a requirement that men must be at least 74 inches tall. What percentage of men meet that requirement? Well, percentages and probabilities are the same thing. So this is asking us what's the probability that a man is at least 74 inches tall. And above you have some information about normal distributions for heights of men and women that we'll use for this problem. So first get your picture drawn. I've got a normal curve. I've drawn the mean down the middle. For men, the mean is 69 inches, and then I want to know at least 74. So that's 74 or more. So I've got that part shaded in. And then if you want to, pause it and see if you can use Normalcdf to find the answer for this. Well, this is one of those cases where the shaded part is less than half. So I'm going to do 0.5 minus. And the part that I'm taking out is that piece between 69 and 74. So I'm going to do 0.5, which is the half all the way from 69 over. And then I'm going to subtract Normalcdf of the portion between 69 and 74. That'll take that extra part out and just leave me with the shaded part to the right of 74. So that comes out to 0.0371, which is 3.71%. Let's try one with women's heights. U.S. Army requires women's heights to be between 58 and 80 inches. So let's find the percentage of women who meet that height requirement. Okay, so we get our picture drawn. Mean for women is 63.6, got that coming down the middle, and we want to know the percentage that are between 68 and 80. With this one, it doesn't end up mattering so much whether it is more than half or less than half, or even which direction the shading goes, because we're between two values, and when you're between two values you can just do Normalcdf and it will find that portion for you. So we've got Normalcdf 58 to 80, the mean and the standard deviation, and that comes out to 0.987, so 98.7%. So 98.7% meet the requirement. It really doesn't seem like too many women are being denied access to the Army because of their height. And one last example, so replacement times for CD players are normally distributed with mean of 7.1, standard deviation of 1.4. Let's find the probability that a randomly selected CD player will have a replacement time of less than 8 years. So go ahead and pause it and try that on your own. Here's the picture. Mean coming down the center of the curve is at 7.1, so 8 years would be just to the right of that, but we want the probability of it being less than 8 years, so we're going to shade to the left. So that's what the picture is going to look like. And so this is a case where we've shaded in more than half. So I have 7.1 over to the left is half of the curve, and I need to add on that extra little piece between 7.1 and 8. So I'm going to start with a half and add Normalcdf for the portion from 7.1 to 8. And then the mean and the standard deviation. That gives me, when you do 3 significant digits, it's 0.740. So if you did leave it as just 0.74, that would be okay. And so that is 74.0% chance that that CD player would have a replacement time of less than 8 years. So I'm going to go ahead and make a video with the actual showing of the calculator and the screenshots and walking you through that. So if you need a little bit more instruction on actually typing these things into the calculator, you can go to that other video. If you're struggling a little bit more with the setup and figuring out when to add, when to subtract, you may want to go back through and look at these slides a little bit more. I would make sure that you're pretty comfortable with this part before you try and go on to the next one, or else you're just going to get kind of overwhelmed.